In page 121, we have more definitions that we can use to find dy by dx. When y equal x to the power n, then dy by dx equal n multiplied by x to the power n minus 1 for all real values of n. We said previously, when f of x equal x to the power n, then the derived form is n multiplied by x to the power n minus 1. We reduce 1. Then you can also differentiate the general quadratic equation y equal ax squared plus bx plus c using the definition that dy by dx equal to the limit as delta x tends to 0 for f of x plus delta x minus f of x divided by delta x. Let's now do this definition manually to find dy by dx. Knowing that we have y equal ax squared plus bx plus c. Then for f of x equal ax squared plus bx plus c, we can say f of x plus delta x. Instead of x in the f of x, we are going to replace each x by x plus delta x. Then it will be a multiplied by x plus delta x squared plus b multiplied by x plus delta x plus c. We can now expand x plus delta x all squared aside. Then it will be x plus delta x multiplied by itself twice. This is going to be, we can split the first term, x multiplied by x is x squared, x multiplied by delta x is x delta x, L delta x multiplied by x is x delta x as well, and delta x multiplied by delta x is delta x squared. This is going to be equal x squared plus 2x delta x plus delta x squared. Let's substitute it in f of x plus delta x. It will be a multiplied by x squared plus 2x delta x plus 8x or delta x squared plus b multiplied by x plus delta x plus c. Let's now subtract f of x, which is ax squared plus bx plus c. To do so, we have to expand the brackets. Then ax squared plus 2ax delta x plus a delta x squared plus bx plus b delta x plus c. Now we have to multiply the minus sign by all the terms inside the bracket. We will get minus ax squared minus bx minus c. Now let's remember, this is a subtraction for f of x from f of x plus delta x. Collecting the like terms, now ax squared is cancelled with minus ax squared, bx minus bx, c minus c. The remaining will be 2ax delta x plus a delta x squared plus b delta x. Let's substitute, or before we can take delta x outside, so the remaining is going to be delta x multiplied by 2ax plus a delta x plus b. This can be now substituted in the numerator of dy divided by dx. So it's equal to the limit as delta x tends to 0 for delta x multiplied by 2ax plus a delta x plus b all divided by delta x. Delta x in the numerator and the denominator cancel each other. If we assume that delta x tends to 0, then the remaining is going to be 2ax plus b. We substituted 0 instead of a of delta x, which is a very small value and neglected. Then the remaining for dy by dx is equal to 2ax plus b. This is the differentiation for f of x. Therefore, when y equal ax squared plus bx plus c, or the general form, then dy by dx equal to 2a plus b. We can think about it as considering the three sketches below. Y equal ax squared, the first term, and in the second sketch y equal bx, the second term in the f of x, and the third sketch y equal c. For y equal ax squared, the gradient is a multiplied by 2x. For y equal bx, the gradient is b, and when we have y equal c, the gradient is 0. Combining all of these terms together, then dy by dx for f of x is going to be 2ax plus b. In the upcoming tutorial, we will learn how to use this definition.